You're welcome to the day 4 of the chemistry series with Excellent Simplified. And today we are going to be looking at test for purity. If you are given a substance, either solid or liquid, how do you know if that substance is pure or impure? Now, some of the criteria to test for purity of a substance, either liquid or solid, are melting point, boiling point, the density of the substance, and the freezing point. So I'm going to be explaining these four briefly and simply. Let's go. Now, the melting point of a substance can be used to determine if the substance is pure or impure. How do you know if solid is pure or impure? You can use the melting point. Now, for a pure solid, the melting point for every pure solid is sharp, definite, and with a short melting point range. What does that mean? If I have a solid, let's say ice has a definite melting point. If it is pure, then ice must melt at that particular point, at that particular temperature. Ice must melt. But if it is not pure, then it can go below or above. Do you understand? Now, melting point for every pure solid is actually fixed. It's actually very sharp. Not, it can be, let's say if the melting point of the substance is supposed to be 100, then if you check the melting point of that substance, then it must be 100. It must be 100. That's just an example. Now, if there is an impurity, impurity will lower the melting point of a substance. Now, let's be practical. If you have cube of ice and you want it to melt very fast, add an impurity like salt. If you add salt to ice, it will melt fast. Why? That salt is an impurity. An impurity lowers the melting point. Lowers the melting point. Now, when we say melting point, that point is actually temperature. So if the temperature that the ice was supposed to melt, take for example, if the temperature that ice was supposed to melt is 10 degrees Celsius, assuming it's 10 degrees Celsius, if you add an impurity, it will lower the melting point to say like 7 degrees Celsius. So at 7 degrees Celsius, the ice will start to melt. Do you understand? So impurity lowers the melting point of a substance. Impurity lowers the melting point of a substance. Now, the next one is boiling point. Now, the boiling point for every pure liquid is sharp, definite, and with a short boiling range. What does that mean? Water boils at 100 degrees Celsius. That is a known fact. Water boils at 100 degrees Celsius. So if I take water from the tap, put it in a container, and start heating it, then I put a thermometer inside the heating flask, the boiling flask, to be measuring the temperature. If at 100 degrees Celsius that water does not boil, then that water is not pure. So you can use that to test for purity. Now, what does impurity? Because this exam area, impurity does what to the melting point, impurity does what to the boiling point. That's exam area. Now, we've seen that impurity lowers melting point, reduces melting point. Now, for boiling point, impurities raise the boiling point of a substance. So if there is impurity in that substance, the melting point will be high. Back to our water example. If you are boiling water, if the water is pure and you put your thermometer inside, if the water is pure, it will boil at 100 degrees Celsius. But if you put an impurity like salt inside, you can try it. Put salt inside the water as an impurity. Put thermometer inside. You see that at 100 degrees Celsius, the water will not boil. Maybe it can boil like say 110 degrees Celsius or something, depending on the quantity of impurity, salt inside. Do you understand? So for every pure substance, the boiling point is fixed. But if the boiling point is not sharp or with a very high range, then there is an impurity inside. So we've said two things here. Impurity lowers melting point and impurity raises freezing point. How do you remember that? Just know that if you add salt to ice, it will melt fast, lowering the temperature, the melting point. That's impurity. If you add salt inside water, it will increase the boiling point. All right. Now, the next one is density. Now, for pure substances, for pure substance, the density is always definite and constant. while that of an impure substance is higher than expected. The density of this book, if it's a pure substance, I'm using, okay, let's say the density of diamond is fixed. Let's assume it's 2.51 grams per cm cube, or anything they are using to measure it. I'm assuming that the density is 2.51 grams per cm cube. That's for pure diamond, assuming. Now, if it is not pure, you see that impurities will increase the density, because impurities have their own mass now. So they will increase the density of the substance. So impurity increases the density of substances. The last one I'll talk about is freezing point. Freezing point. At what temperature does a substance, a liquid, freezes, turns into solid? Remember, freezing is conversion from liquid to solid. Now, every pure substance has a definite freezing point. Like water freezes at 0 degrees Celsius. So if you put it in your fridge, the temperature will be reducing until the temperature there is 0 degrees Celsius. Your water turns to ice, freezes. But if there is an impurity in that substance, then you discover that the freezing point will be lowered. So impurity lowers freezing point. What does that mean? At 0 degrees Celsius, the water is still liquid until the temperature lowers to say like -2 degrees Celsius. Then it can turn to ice, because impurity will lower the freezing point. -2 is lower than 0. So it will at 0 degrees Celsius, the water will not freeze because of impurity. It will be going lowering until it gets to say -2 degrees Celsius, depending on the quantity of impurity inside. Then the water can freeze. So impurity lowers freezing points, increases density, increases boiling points, lowers melting point. Please take your time on this, because this is in every exam you're preparing for, post-UTME, JAMB, WAEC, NECO, you will see something like this. Please take notes. And if you've not subscribed to my channel, please click on the subscribe button. And just so you know, this is a series video. This is day 4. I've done day 1, day 2, day 3, this is day 4. And the aim is to finish chemistry from the beginning to the end. So I started from introduction to chemistry, and it's in this playlist, in the playlist here. So just go to the playlist, you see from the first video to where we are. So the aim is to finish chemistry from the beginning to the end. If you have problem with chemistry, just follow this series and you'll break that chain. All right, if you've not subscribed, subscribe. Do me a favor, share this video and like, comment. If you don't have anything to comment, at least say thank you in the comment section. See you in the next series. My name is Excellence Simplified.